All right. Well, I think we should start. Do you all hear me? Well,
Yeah, Laura, start the presentation mode.
okay. I do.
Good.
Well, welcome everybody, and thank you for being with us today. This is the first webinar of a long list. A webinar from the Action and Expert group of the SCAR Geoscience group. But before leaving the floor to the first two speakers of today, I just like to introduce what SCAR is. Maybe some of you don't know SCAR. And just say a few words about geoscience in particular. So SCAR is the Scientific Committee for Antarctic Research. It's a thematic organization of the International Science Council. I took these slides from the portal and I put the address in the upper part of the slide so you all can go back and check some more details. But what SCAR does since 1958, after the International Geophysical Year, is to develop and coordinate the international scientific research in Antarctica and in the Southern Ocean. And since the very beginning, it developed a large network of thousands of scientists working together with the ambitions to make Antarctic science for the benefit of society and to develop knowledge, to advance our knowledge, and also to provide some advice to the Antarctic Treaty consultative meetings. So basically, SCAR has been instrumental for many young and senior scientists to get together, discuss from different countries, and develop top-level Antarctic science. How SCAR works has basically a president, Gary Wilson, which is the guy in the middle here. Let me use the pointer. This is Gary Wilson. He's the president. He's elected by the national delegates. And the executive committee, which is made by vice presidents, also elected by the SCAR delegates, and a very nice secretariat led by Chandrika Nath, who is the executive director, this person here. And the executive com and president are elected every 4 years, basically, with the vice president being in charge for 2 more years. How it works? It works as with scientific business groups divided by disciplines. So geoscience, life science, and physical science, who are includes a series of subgroups, which are action and expert groups, with a life span of about 8 to 10 years. And in particular, the geoscience, which is the one I'm leading together with Jesus Galindo Zaldivar from Spain, Naresh Pan from India, and with the support of Matilde Ferrante from Italy, is divided into these groups. And today we will hear about the ADMAP. And for the rest of the webinar, we will hear about AntPass, AntVolk, Geocon, Giant, IPSCO, and IcePro, but also from other groups which are cross-disciplinary. So we share, for example, Antos and groundwater and rings with the other life science and physical science groups. So just a few words about the calendar. Don't forget to subscribe to the Geoscience mailing list if you haven't done it yet, so you will know about any news. about geoscience. So today's webinar will be ADMAP from Graham Eagle from AVI and Antonia Roppel from the BGR, both are from Germany. And it will be about the Antarctic Digital Magnetic Anomaly project. And after our webinar of today, we will have the other action group and expert group webinars, and those are the dates. So if you don't know the dates yet, you can visit the Geoscience portal. You have this calendar there as well. And you can also register for the next webinar. I think the link will be the same, no, Matilde? We will use always the same Zoom link for all of the webinars. So you don't have to register again, actually, but yes, you can inform your colleagues about this link if they want to attend. Okay, so now before I forget, then there will be other 3 groups still to be scheduled, but I spread the news as soon as we have the dates. Before I forget, I just want to let you know, in case you don't know it yet, that we have the International Symposium of Earth Antarctic Science in August in Punta Arenas. So if you haven't done it yet, please register, and yeah, that would be a very good way to meet your colleagues and discuss about the science and future initiative. Okay, so I just leave the floor to Graham and Antonia. So please, I stop sharing. Thank you. If you have any question, we can leave the question time at the end, or you can write in the chat. So we are very happy to answer.
Okay, can everyone hear me?
Yes.
And
Yes.
see my screen? Super. Okay, so yeah, thank you, Laura, for introducing us. Yeah, welcome to the first of the first webinar on the action and expert groups of the Geosciences division. Yeah, I'm Graham Eagles. I'm head of airborne geophysics at the Alfred Wegener Institute in Bremerhaven in Germany. And I'm one of the 3 chairs of ADMAP. And our early career researcher, Toni Ruppel, you're going to meet her for the second half of this presentation when I've finished in a few slides' time. So just to introduce here on the first slide, we're looking down at Antarctica with you can see it shining through the most recent version of the ADMAP compilation there. And I'd just like to say that this kind of nicely illustrates the usefulness of magnetic anomaly data in Antarctica, because without that colorful background there, we would just see a white blob, illustrating the fact that if you want to get at lithological variability in Antarctica, and you don't have outcrops, which is the case for 99% of the area, then you need to have another method. And magnetic anomalies are probably the best way of going about getting that information, because the signals for thermal reasons are coming out of the uppermost 10 to 15 kilometers of the crust. Okay, so how am I going to advance here? I'm not advancing. I'm going to try it like that. There we go. So here's our agenda for today. We're going to come back to this every couple of slides just to keep you up to date with where we are in the presentation. So I'm going to start with talking for a slide or 2 about our data products and their integration. If I can find the button to advance here, yeah.
Graham?
Yes.
I think you changed the Did you start from the beginning?
Oh, am I using the wrong one? I'm using the wrong one. Sorry. Yeah. Tony, this is your part, isn't it?
Yes.
So
So I was just wondering.
yeah, sorry about that. I'll start again. I hope
Sure.
I haven't given away too much information here. Here's the agenda. Sorry, everybody. Yeah. So we were called into existence 30 years ago.
So I cannot see your screen at the
you
moment.
can't see my screen. Oh, this is going horribly wrong, isn't it?
No worries. Just take your time.
Do we see it now?
Not yet.
No. Okay, let me go to Zoom and I'll try sharing again.
Yes, that looks good.
Is that better?
I do see, yes.
There we go. So the lightning struck me again. Here's our agenda.
Okay.
So our name is ADMAP. We are, that's short for the Antarctic Digital Magnetic Anomaly Project. And this is our brief introduction. So we're data driven, and our goals are to harmonize the magnetic data sets that are collected around Antarctica as like little postage stamps in geographically isolated areas, and it's a fairly big task to get those postage stamps to all fit together to make a continuous picture with no large artifactual faults between them. Having harmonized those data, our goals are to make sure that everyone can get hold of them, that they have access to them, and to use them freely in their own, to be able to use them freely in their own research. So that kind of research, and we'll come on to a couple of examples later on, might be directed towards interpretation of the crustal structure and its variability underneath the ice sheet, or to use Antarctica and its geological variability in even larger context for things like tectonic reconstructions of plate scale processes and products, things like plate kinematic reconstructions and paleogeographic reconstructions. And in recent years, we've come to more often be involved in using these data or in making these data available for estimates of heat flow via Curie depth estimation, which is particularly important in a glaciological context. So our organization consists of a large number of people, which we've reached this mass over, as I've said, about 30 years of existence. We have three co-chair people. One of us is retired, Detlef de Masker, who was formerly a colleague of Antonia's at the BGR in Germany. Fausto Ferraccioli, who many of you know from OGS, and myself. Our early career researcher officer is Antonia, who you'll meet soon. And we have 5 further members on the steering committee, 2 from the United States and a South Korean member, 1 from Australia and 1 from Russia. A Russian member, Sasha Golinsky, is also at the same time our data manager, and with that, one of the most important people in a data-led expert group like ADMAP. So beyond that steering committee, we have a further 50 plus members from all around the world, from Germany, China, Italy, Spain, Denmark, Argentina, Japan, the list goes on. I won't mention everyone's countries of origin there. So within SCAR, we have informal, but nonetheless very strong and useful links with a number of the expert and the other expert and working groups and action groups, sorry, including Giant, who you'll be meeting in coming weeks, Rings, who we hope to get scheduled for this webinar series, with their focus on the grounding line. Giant, sorry, has a focus on geodesy and gravity, so in particularly with gravity being the other potential field method in geophysics alongside magnetics, there are strong methodological similarities with Giant, or between Giant and ADMAP. AGE for it's the geological evolution of Antarctica, that's coming into being right now, and its predecessor, or one of its predecessors, CGG, Connecting Geology and Geophysics, we had very strong connections with, and I'm sure we'll have strong connections and overlap with AGE in the future. And instabilities and thresholds in Antarctica as well, we have crossover membership with and have provided data for. So back to the agenda. A few words now about the collection of magnetic anomaly data in Antarctica, and how then we go about putting those data together into compilations that can be used by the community. So primarily we're talking about near surface data, but also these satellites, so the very high altitude data collection plays a role as well. So by near surface, I mean aircraft, manned and unmanned, and ships, but also, as I've seen today on a paper from our Russian colleagues, even still to this day, we have people out in Antarctica collecting data on foot, carrying a magnetometer on their back. So we're working at all scales and working very hard to collect those data and collate them for you to use. So yeah, we've got a couple of slides there showing a Basler, a converted DC3 in the top left there, with the magnetometer in the probe on the nose there. And you can see that those data are being collected typically in combination with radar data. Those are the antennas under the wings there, and gravity anomaly data as well. You can't see the gravity meter, it's inside the cabin. If we're working with smaller aircraft or unmanned aircraft, then the range of equipment may be reduced to just the magnetometer or just some subset of those. The icebreaker there would typically be towing a magnetometer if collecting magnetic anomaly data, towing on a cable some meters behind the ship. Yes, and up in space we have the data from dedicated and non-dedicated magnetic missions like CHAMP and SWARM. So for the methodology now, I will talk about the example of our most recent compilation from 2018, ADMAP 2. So we have a few words here from Sasha Golinsky, our data manager, who's the central person when it comes to collating the data. And he's written down here that the data that we had for ADMAP 2 couldn't be directly merged with its predecessor, ADMAP 1, which was rather sparser. And instead, he had to start again from scratch, working on all of the individual magnetic anomaly profile data, reprocessing those into regional grids, and then combining those regional grids into an Antarctic continental scale compilation. And yeah, sorry, I should really have been showing you those bullet points there whilst I was summarizing Sasha's workflow. So perhaps if we want to, we could go back to that slide later, but in order to keep things moving along, and you having had some time to read that, I'll move onwards. The final product there, for most of us anyway, or the flagship product is a 1.5 kilometer resolution low pass filtered continental scale grid that you've seen a couple of examples of already. So on the left side of the screen here, we can see ADMAP 1. That was our first product from the beginning of the 21st century there. It came out around about 5 or 6 years after the grounding of ADMAP as a SCAR expert group, with its goal to unite all of those fragmented magnetic data sets dating way back to the International Geophysical Year, some of them 1957. So yes, there's the first data product from 2001. We updated that with a large number of new data. I think Tony's going to have exact numbers or more precise numbers later on in terms of line kilometers of data acquisition. So the second product came out in 2018, and we've had a couple of interim updates since then. So last year, one of those was filling those white gaps, or the slightly smaller white gaps in the second version, with satellite anomaly data. And also last year, we got to the point where we could make the gridded anomaly data available in open source, in a variety of open source formats for people who are not using the GeoSoft software that ADMAP has traditionally been collated within. So back to our agenda here. We're going to now look at a couple of applications, the kinds of things that our data have been used for and are being used for. I'll start with a bit of an autograph, or a quick look around Antarctica, using now the second version of the ADMAP compilation, which you can see on the left-hand side of your screen there. So hopefully, if you've got the first version still in your mind, you can see now the second version has many fewer of those white gaps where nobody's been collecting data, and those gaps are also smaller. We're now in the position with this a compilation to state that Antarctica is a collage of crustal blocks, rift systems. Excuse me if that was a loud noise for everybody. I think my dog's just knocked over a big pile of bottles. Crustal blocks, rift systems, volcanic provinces, and the surrounding areas of oceanic crust. We hope that I hope that we can also show you with this signature here that we can use the compilation, the second version of the compilation, to correlate Antarctic geology away from the handful of outcrop information that we have well into the continental interior. Use with a couple of examples here now. This is one that's been around or been known about for a very long time now, the Pacific margin anomaly, or sometimes the Pacific coastal magnetic anomaly. This runs for a couple of thousand kilometers all along the until recently active subduction margin of Antarctica with the Pacific Ocean. And it's the expression of crustal scale magmatic intrusions deep in the crust, probably mafic intrusions that are the product of a very long history of subduction along the Pacific margin there. We'll move now into the Weddell Sea as an example of an area of oceanic crust around Antarctica. We can see here quite spectacularly displayed the pattern of magnetic reversal anomalies in the Weddell Sea that tell us something about its history of seafloor spreading. since late Jurassic or early Cretaceous times about a fairly close by Euler rotation pole somewhere over here. You can see all of those magnetic anomalies here, these stripes converging towards the west, towards where the Euler rotation pole would have been. These data are particularly useful, not just in the Weddell Sea, but all around Antarctica for reconstructions of the global plate tectonic circuit, in which Antarctica is a key link for getting from the plates of the Indian Atlantic hemisphere to the Pacific Ocean. And that they have big implications for a large use in geodynamic studies. A couple of examples now of recent papers using magnetic anomalies from ADMAP in the literature. So here's one from Tom Jordan and colleagues, a review article covering the history of West Antarctica. And you can see there in the slide in the middle, the bottom half is directly using the ADMAP products for this review. Another example here, this is one of my own pieces of work with the suggestion of the motion of a small plate in the Weddell Sea region. Here I was using ADMAP together with Hannes Eiserman, my co-author, to help understand an isolated set of seafloor spreading anomalies that we had mapped much further to the north in the area close to the island of South Georgia. Here ADMAP is being used in the Wilkes Basin region to generate Curie depth estimates, and from Curie depth to go a step further to crustal heat flow. This is work done by Max Lover, who's I've seen is listening today, and some other colleagues as well from British Antarctic Survey and elsewhere as well. One further application that magnetic anomaly data from ADMAP have found themselves being useful for in recent years is estimation of bathymetry underneath the ice shelves. So here's another example, and again, I can mention the name of Hannes Eiserman, my colleague, who led this study. Here, the magnetic anomaly data are being used to precondition estimates of crustal density, using associations between, or hoping for associations between density and magnetic susceptibility. And from the density, we can then move to a constrained inversion of gravity anomaly data for bathymetry in these areas underneath the floating ice where we can't get a very good idea of bathymetry using other techniques unless we're prepared to spend a lot of time and effort on seismic acquisition under very difficult conditions. And one last example here before I hand over to Tony, and you get to see the second half of the presentation in its proper context. An example here from Sasha Golinsky and colleagues working at very high resolution with an unmanned acquisition platform for almost outcrop scale interpretation of geological variability there over in the Bunga Hills area of Wilkesland. So that's those are very new data. I think they were collected last season or the season before, and I think personally I think that the map they've produced is absolutely beautiful, and this is a quick look into the future of ADMAP. I think that we might be looking at data with quality like this, hopefully, more and more frequently in the future. So I really am happy to hand over to Tony now and stop sharing my screen so that she can share hers.
We'll see if everything works out. Let me know if you can see my screen.
Yes.
Let's see. Yeah. Okay.
Yeah.
Yes. Thank you, Graham. And my name is Antonia Ruppel. I work as geophysicist at the Federal Institute for Geoscience and Natural Resources. We have our own helicopter magnetometer system, and that's why I got involved into ADMAP as data provider. And since the beginning of my career, I'm involved in ADMAP. And I guess that's why I'm here. And I want to give you now an overview and continue with the next section and focus on data products provided, and also highlight where the data is made available and how it can be accessed and used by you as the broader scientific community. So it's more a short overview and a hands-on session. And this slide gives you once more an overview of how ADMAP evolved. We have already heard about it. And around 2000, ADMAP 1 was a single magnetic anomaly grid in a software-specific format. It was GeoSoft. It has had no formal release paper, but it was an important first step towards the long-term development. Then we had ADMAP 2 in 2018, expanding the data set, including multiple grids and profile data still in GeoSoft format, but also accompanied this time by a formal release paper, making it much more robust and citable resource. And as we already heard, is that since 2024, ADMAP 2 has been accessible in multiple formats. And we're now moving towards ADMAP 3. It will be the next full version expected in 2025, maybe, hopefully, or beyond. And with the ongoing effort to achieve a complete coverage. A new publication is also planned. And in the long term, there's a group that aims to provide regular updates and potentially offer also online data processing services. Yeah, and I'll come back to this in a bit. Yeah, to put this into perspective, ADMAP 1 included about 1.5 million line kilometers, and ADMAP 2 added roughly about 1.9 million more, and clearly increasing the total coverage. As we see in the figure on the right-hand side of both compilations. And for ADMAP 3, around 1,770,000 new million line kilometers of survey data are indicated here in various colors. And they are already available and will be incorporated into the next version, helping us to move closer to the complete coverage. Yes, and let's now move to the data products. The data products from ADMAP are easily available for download through the platforms such as the Pangaea Data Center, ensuring open and straightforward access for the research community, also the geoscientific community. And this slide highlights the first ADMAP data release provided by Wolinski et al. And as already mentioned, there is the new delivery in multiple formats to improve the accessibility and usability for other platforms. Yes, now let's talk about the data integration. ADMAP 1 has been successfully incorporated into major international magnetic anomaly compilations like the World Digital Magnetic Anomaly Map, which was released. I think the latest release was 2015, so it's still at map 1. And we have the Earth Magnetic Anomaly Grid, the latest release 2017, and there's still also ADMAP 1 included. But overall, integrating ADMAP data into these global models also helps to ensure consistency across the continent and supports a wide range of geophysical and tectonic research beyond Antarctica. ADMAP 1 and ADMAP 2 are ready to use in open data portals and polar GIS platforms such as Quantarctica, GMT, or Gplates. We've also provided Google Earth KMSAT file, and yeah, at the moment they are also partly integrated in some of these systems. And looking ahead, I already mentioned the group of authors that is preparing to launch the project called ADMAP. It's an open, or will be an open online service for leveling new survey data quickly into the ADMAP 2 context, and I'll return on this shortly. Yeah, let's now look to a practical example of how ADMAP 2 can be integrated, for example, in Quantarctica. I think a lot of geoscientists are using already Quantarctica. The ADMAP 2 grid will be included as delivery in the upcoming new release of Quantarctica 4. While the version isn't out yet, yeah, we're waiting for it and looking forward to it. And in the meantime, you can easily add the geotiff file provided on the Pangea data portal. And yeah, I'll just guide you quickly through it. I hope you can see the video. This is Quantarctica. Quantarctica provides a variety of data sets. Yeah, you can already load ADMAP 1 pretty easily. There are other data sets, so you can combine the data and explore the data really easily. To include ADMAP 2, you just go on the website, click on the View Data Sets, download, for example, this TIFF file. It's the ADMAP 2 without the satellite infill. Store it at a place where you find it, where you can find it. Just highlight the geophysics layer and just drag and drop the data into your project. It will appear in gray color scale, and you can easily adjust the color scale, choose the color scale you like. You can adjust the color bar range, which I did here, with an upper limit of 300 and a lower limit of 300 nanotesla, for example. And now ADMAP 2 is ready to use, and yeah, you can explore the data. In my project, I already loaded the geology from the GeoMap project. It's also provided in a compatible GIS format, and then you can compare the anomaly data pretty easily with outcrop information and see, for example, if anomalies fit your volcanic sequences or whatever you're interested in. Yeah, okay. That was a short introduction about how to use the geotiffs. And yeah, let's move on with the presentation. And for those using other platforms, the NetCDF version of the data release is fully compatible with GMT and Gplates, and the KMSAT version is available for Google Earth. Yes. Yeah, coming back to ADMAP, which was already in the introductory slide of this agenda item. And to just give you a practical example, imagine you have conducted a new airborne magnetic survey, and with ADMAP, you could upload the new data and the service will automatically level it and to match the ADMAP 2 grid. So the result is fully harmonized data set ready for your analysis without the need of time-consuming manual processing. So in between ADMAP 2 and ADMAP 3, it will be a good, good product to just integrate your data on the fly. And altogether, these efforts aim to make Antarctic magnetic data more accessible and also compatible across the geoscience community. Yes, so now let's take a closer look at the main challenges we face in collecting and working with Antarctic magnetic data. First, we have the harsh environment, which is the major obstacle. We have extreme weather conditions and remote, difficult terrain that limits our field work opportunities and significantly increases the logistical costs. Then there is the issue of uneven data coverage, as indicated in this figure. Magnetic survey density is generally higher near coastline and research stations, and there are significant gaps in the inland and remote regions. That's still a few of the ADMAP 2 coverage. We will be able to fill some of these gaps with ADMAP 3, but we'll see later on that there are still some gaps remaining. And adding to this, there is the data quality, which often varies because it comes from many different sources with differing resolution. We have high resolution surveys, for example, with the unmanned vehicles or ship tracks or survey grids, which have to be incorporated. And another challenge is the diverse data sets that need to be merged, and it requires a complex processing, which can also sometimes introduce errors. And on a broader level, the international scientific cooperation that is crucial, but also challenging due to political and logistical issues. And finally, securing funding is essential to maintain ongoing data collection, the processing capacity, and international cooperation. And overall, just to understand these challenges, helps highlighting the complexity behind the data and behind ADMAP and the effort that's required to improve our knowledge about Antarctica's magnetic signature. So I'm coming to the end of the webinar, but I'll now just quickly show you the new survey data that will be integrated into the new ADMAP product. And this slide highlights several recent surveys that are already available and will contribute to the next generation. These are a lot of surveys provided by several nations that will be incorporated, and this includes the effort aimed at closing the polar gap, for example, the last remaining area within with the limited data coverage. The Rosetta Ice Project that has provided high-resolution data across the entire Ross Ice Shelf. We have data from our Chinese colleagues that will help fill major gaps in Princess Elizabeth Land, while additional surveys cover the Recovery Lake region and interior Dronning Maudland. And further contributions come from joint German RV-BGR campaigns in Dronning Maudland. We have new data from the British Antarctic Survey collected as part of the Filchner Ice Shelf System project. Several Russian Antarctic expeditions have added important magnetic data over Princess Elizabeth Land, Queen Mary Land, and Wilkes Land. And finally, new data from the Spice Cap survey by the University of Texas, Institute for Geophysics, and the Australian Antarctic program will be included. So there's a whole bunch of new data for the next version. And last but not least, there are several new shipborne surveys that also provide valuable magnetic measurements along the coastal and shelf regions. Yeah, and that's how the full coverage will look like with all 3 versions. And yeah, I just applied some transparency, and the remaining gaps in the data coverage become clear, emphasizing that there's still important work ahead for ADMAP. Yeah, and if you like to get involved, please reach out to our chairs or data managers. Yeah, thanks for listening.
Thank you very much, both of you. Very comprehensive and interesting talk.
Yeah, and we're happy to answer questions. Yeah.
Yeah. So the way you collect the data is basically via email. You meet every 2 years at the SCAR conference. Generally, all action expert group meet at the SCAR Open Science Conference, but also during more frequently sometimes. So how do you, what's the procedure that you generally use for interacting and for exchanging the information within your group?
We do try to meet at the OSCs, and obviously, as given the fact that we're such a large group or such a dispersed group, we also try as often as possible to put together something like a splinter meeting at EGU or AGU. And the ISAES meetings are also a great opportunity for that. I think things have been a bit difficult the last few years since COVID, but it's going to be very rewarding, I think, to get back into the rhythm of regular meetings at OSCs starting next year.
Is there any question in the chat? Or if you want to ask something, you can just show up and ask a question.
There is a question from Hannah Lott, which asks, can you explain more about the processing to integrate different data sets into ADMAP?
The processing to integrate different data sets into ADMAP. This is where I'd really like to have Sasha Golinsky here, because this is to a certain extent a magic process that happens with him. But well, typically what he's doing is applying at a very high level of skill, well-known techniques for combining line data together using procedures called known as leveling and micro leveling. So what tends to happen is that when you've gathered your data and you plot the individual profiles of magnetic anomaly data over each other, you could see, despite the expectation that where 2 lines cross each other, they should have measured exactly the same magnetic anomaly value, that they don't. And there are various reasons for why they shouldn't or why they haven't. But under the assumption that you should be measuring the same static value at any particular crossing point, you can generate a network of correction values that you then apply to the individual line data one by one in such a way that the overall value of misfit at the network of cross points is reduced as far as possible. So that, in a nutshell, that's what leveling is about. That's the 3rd point there. The point above, cleaning, I suppose, yeah, it's written there, visual inspection for spikes, gaps, and diurnal variations. So these are many of the reasons for the fact that, that we get a mismatch at those cross points. So the magnetic field doesn't just vary according to what rock types we encounter in the environment, but also all the time due to solar activity, and simply due to the fact that as we spin as a planet, sometimes we're facing the sun and other times we're not. So all these things need to be accounted for and corrected for. And eventually, after having reduced the level of misfits in a network of crossing points, you have a grid that typically portrays a smallish area, and with where you have grids that neighboring grids that touch each other, then there are frequency domain techniques for getting those grids to merge seamlessly, and that's done within a at the moment it's done within a proprietary setting with the Geosoft software that we're lucky to have for ADMAP.
We do have another question, Grime. I think it's better if you read it, but the question is from Leonardo Ueda, who asks, how do you handle merging dataset from different decades? Because the IGRF direction changes between them.
Yes. Well, you hope, I guess, yes, that the direction changes. So the idea of an IGRF correction is, of course, that you don't have that decadal variability anymore in there. So this depends very strongly on the accuracy and reliability of the various IGRF generations that we're using. So typically, what would happen, or what Sasha would be trying, is multiple IGRF corrections on the older data in order to see whether a correction had been applied in error, or a better version of IGRF, or a better candidate IGRF or generation has been released since the time of the original acquisition. So there's a lot of it's not really trial and error, but there's a lot of repetitive work in finding the best combinations. So, sometimes I start, if processing is causing me some problems, I start beginning to think to myself that it's more of an art than a science producing these maps. But of course, it is a scientific process. So there's something, sorry, it's not about the IGRF correction itself. The final anomaly is the crustal field projected onto the IGRF direction. So different grids from different decades will correspond to physically different meanings of anomaly. Yeah, I'm not sure I can fully follow that question. The different grids from different decades will... rather than me scratching my head here, Leonardo, can we perhaps take that offline? To take this outside, man to man, if that's okay. I think it might be something that's easier to understand what your question is about, and for me to put together an answer in a setting where we're not going to be giving 30 other people a headache. Okay, yeah.
I have a question about the magnetic data collection. Do you actually know if each of the Antarctic survey may collect some magnetic data, because it would be nice. I mean, it's not a big deal. As far as I know, if you have the instrument on board and someone who can take care of it, it's quite an easy job. So it may be worth to spread the information more broadly in the community. For example, even though you have an oceanographic cruise, maybe you can have your, magnetic data collection on transit, and maybe this is something that we can think more carefully in the future. What do you think? As a strategy to collect more data, to fill the gaps, to have a more comprehensive data collection.
Yeah, I think
Maybe you thought about this already. I don't know if you have a plan.
no, of course, I think it's a good idea, especially with all the upcoming initiatives like Antarctica InSync and a lot of vessels going around Antarctica. It might be really good to collect more data, but also towing a bird it's the same like having seismics out there. It's always a little bit risky, and when you go on transects, or you just want to go quickly from one point to another, you do not want to have this instrument out there. So it always depends on the mission and the time the scientific cruise has. So, but we are always happy for every data we can get hands on for ADMAP.
Do you know if the speed should be, I mean, what's the best, the optimized setup for collecting the data from the ship? Because for the bathymetry, it could be, tricky. Because if you on transit, generally you speed up and try to get to the location of the survey as soon as possible. And sometimes the ship speed is not ideal for collecting bathymetry on transit as opportunity data, no? But for magnetic, do you know? I mean, in the rough sea or in very high speed, is it still okay to collect the magnetic data?
Yeah, I don't think it's so the speed has an impact on what kind of dangers you expose your equipment to, but not to the quality of the data.
Is with airborne surveys or with aircraft, we're going much faster than with a ship, for example. And it always depends on the sampling frequency. If you're using 1 Hertz, for example, you get a whole bunch of data.
Do you have a meeting at the ISS this summer? Do you plan to meet?
There's nothing has been
As a group?
formally, there's no formal meeting. So for family reasons, I can't make it there. We're not sure. So the other chair is Fausto, who I can see is sitting there listening to us. But we're not sure, I think, Fausto, whether he can make it or not either. So it's a bit open at the moment whether we're going to be able to turn up and be quorate there in order to talk about anything with any meaning.
So the next opportunity will be Oslo in 2026, then the Open Science Conference.
I think so, yes.
For the people who is online and want to be involved, maybe just contact you, and I think it would be hybrid anyway, so
Yes.
that's the way,
Yeah, please drop us a line, send us an email, and we'll make sure that we'll put you into the list of recipients for people who are told about the meeting when it's beginning to take shape.
Okay, because these meetings are generally open, no? So in the conference, anyone who is curious to know, who would like to be involved, to know more,
That's right.
Generally, action group and expert group get together once every 2 years, and but the meetings are open. So especially for the young scientists who want to, like Antonia, who wants to start working on this specific subject and maybe build a career on this. Maybe a very good opportunity to have an international network and interact with other scientists from other countries. So this is how SCAR works, no? So it's ADMAP is one of the examples. Okay, I don't see any other question. All right, so I thank you very much for your presentation. It was very nice, and I hope to see all of you and even more next time in July 16 for the next webinar, which will be ICE Pro. So it's about proxy and paleo proxy calibration. And yes, have a nice evening or morning, whatever, wherever you are. See you next time.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Bye.